Okay, so we're beginning our notes for 6.1. 6.1 is on polynomials. And we've already talked about polynomials. If you'll remember in one of our sections we had earlier, we talked about the fact that something with one term, I'm just going to kind of write up here, like for example, 2ab was called a monomial. Something with two terms like, oh, I don't know, 2x minus 3 was called a binomial. Remember, terms are separated by pluses and minuses. And then if you have three terms, then that would be something, oh, I don't know, like 5 z squared plus 3z minus 1. That was called a trinomial, and on and on and on and on. So now we already know what those polynomials look like. Now what we're going to do is we're going to start doing operations with those polynomials. And I don't think you're going to find this too difficult. So when we are adding two polynomials, and if you'll look at this, you can see that I'm adding two trinomials, although that is quite honestly irrelevant. It doesn't matter. All you have to do is add the like terms. And remember, terms are terms that have the exact same variable part. So for example, we can add the 2x squared plus the 6x squared. Remember, to add like terms, you add the coefficients and the variable part stays the same. So that's going to be 8x squared. Now we have positive 5x and negative 8x. So if I add positive 5x and negative 8x, that's going to be negative 3x. And then finally, I have the negative 2 plus the negative 8. And if I combine and add negative 2 plus negative 8, I'm going to get a negative 10. And there is what you get when you add those two trinomials. So again, you're simply combining like terms. Let's go over here to B. So of course, since we just did a whole chapter on fractions, we're going to have to throw some fractions in here for you. So first of all, if I am, again, just adding like terms because it's an addition problem, I'm going to combine these two terms because they have the same variable part. So negative 1/4 plus 3/4 is 2/4 m squared, and I know that reduces. We will reduce it when we do our next step. Then I'm going to have negative 2m and a positive 7m. Well, that's going to be plus 5m. And then lastly, I've got a positive 1/3 and a negative 1/12. Now, unfortunately, those do not have a common denominator. So I'm going to go right above here, and I have to do 1/3 minus 1/12. So the common denominator would be 12. So now I would do 1/3, and what am I going to have to multiply top and bottom by to make that bottom into a 12? I'm going to have to multiply them both by 4. And you can see that the last fraction is already over a common denominator, so I don't have to worry about that. So that's going to give me 4/12 minus 1/12. Which I hope we can all agree is going to be 3/12. And yes, I know that that reduces, but again, I'm going to put right here plus 3/12 because it's positive, and we're going to reduce that in our next step because not only does that fraction reduce, so does this one. 2/4, I can divide both top and bottom by 2. So 2 divided by 2 is 1, and 4 divided by 2 is 2. So 2/4 reduces to 1/2. m squared plus 5m plus, what can I divide both top and bottom of this last fraction by? Well, they're both divisible by 3. So if I divide by 3 and divide by 3, 3 divided by 3 is 1, and 12 divided by 3 is 4. So there we go. So again, when you are adding two polynomials like this, you just simply have to combine or add like terms. Let's go to this example right here. Same type of thing. It's an addition problem. So I can combine 5a squared b and 2a squared b. Those are like terms because the variable part's exactly the same. That's going to give me 7a squared b. I can combine negative 6ab squared and a positive 1ab squared. Don't forget there's really a 1 in front of there. And negative 6 and a positive 1 is negative 5ab squared. Variable part doesn't change. And then finally, I have a positive 2 and a negative 3. And if I add positive 2 and negative 3, I'm going to get a negative 1. And there's your final answer. And of course, you can't combine any of these terms because they're not like terms. So that's addition. Now we have to go on to subtraction. Well, hopefully you remember that when we learned how to subtract numbers, we did the rule that when you subtract, you change the subtraction sign to addition, and then you change the sign of the second number. Now we're going to use a variation of that here, except for we're going to change the subtraction sign to addition, and we're going to change all of the signs in the second polynomial. What it is it's kind of like we are taking a negative 1 and we're distributing it all the way through, because of course distributing or multiplying through by negative 1 simply changes the signs. So what we're going to end up with, and we can go ahead and we can eliminate the parentheses now. We're going to have 6a squared minus 2a. Nothing's going to change in there. And now if we think of this as distributing through a negative 1 times negative 3 would be plus 3a squared. Negative 1 times positive 2a would be negative 2a. And negative 1 times positive 3 would be negative 3. So notice what's happened is all of the signs in the second polynomial have changed. And now we go ahead and we combine like terms. So 6a squared and 3a squared gives me 9a squared. A negative 2a and a negative 2a combines to give me negative 4a. And then the only thing that's left is the minus 3 at the end, which doesn't combine with anything. So let's again use that idea of thinking of subtraction as just distributing through the negative 1, because there's really a negative 1 in front of these parentheses. So let's rewrite this expression by distributing through the negative 1. So we're going to have 7p squared q minus 6. Nothing happens here. Negative 1 times 2p squared q would be negative 2p squared q. Negative 1 times 4pq would be minus 4pq. And negative 1 times positive 4 would be minus 4. Now it's a matter of combining like terms. So we have 7p squared q and negative 2p squared q. That gives me 5p squared q. If I cancel those out, now notice I have this guy right here, which doesn't combine with anything. So I'm just going to tail that and not combine it. And then I have a negative 6 and a negative 4, which will combine to give me a negative 10. And there's my final answer. Okay, let's go ahead and do F. Now notice here, we have this negative 1 to distribute here. And look what we have here. We don't have a negative 1, but we have a negative 2 to distribute. So we have to do that distributing first, because don't forget multiplying comes before adding or subtracting. So here we go. The 3a stays on its own. And then negative 1 times a squared is negative a squared. Negative 1 times 4a is negative 4a, so that's it for this set of parentheses. Now we have negative 2 times negative a squared. Don't forget, a negative times a negative is plus 2a squared. Negative 2 times negative 5a, again, negative times a negative is plus 10a. And then a negative 2 times 1 is a negative 2. So if we combine our like terms, I'm looking at 3a, which combines with negative 4a, and wait, don't forget, we also have that positive 10a, so we can combine all of them. So let's add the coefficients. 3 plus negative 4 is negative 1, and negative 1 plus 10 is going to be a total of 9a, and all of these have been combined. Now I've got a negative a squared and a positive 2a squared. A negative 1 and a positive 2 would be plus 1a squared. No, you don't have to write the 1, but it's okay if you do. And then we just have the negative 2 at the end. Now technically you know that it doesn't matter what order you add terms in, but if you check your answers in the back of the book, they may put this term first just because it has the higher exponent. I would accept this on an exam or on a quiz, but let's go ahead and switch these two terms, because then we'll have 1a squared first plus 9a minus 2. And notice there, the term with the highest exponent comes first, and then the next highest exponent, and then no exponent at all. All right, what I would do if I were you is I would pause the video and do G on your own, and then watch me do G and check to make sure you're okay. All right, so I'm going to, again, distribute through first a negative 4, so that'd be 6x, and then negative 4 times 2x is negative 8x. Negative 4 times negative 5 is plus 20. Now there's really a negative 1 in front of this set of parentheses, so I'm going to distribute the negative 1. So negative 1 times x squared is negative x squared. Negative 1 times negative 4x is positive 4x, and negative 1 times negative 1 is a plus 1. Now let's go ahead and combine our like terms. Now I happen to notice that this guy is sitting all alone. It has the highest exponent. It has nothing to combine with it, so I'm just going to put that one first right away. I'm going to cross it off because I'm done. Now I've got 6x, negative 8x, and don't forget the positive 4x here. So what's 6 and negative 8? That's negative 2. And negative 2 plus 4 is positive 2x. So now all of those have been combined. And now finally we have the positive 20 and the positive 1, which will add to give me positive 21. And there are your notes for 6.1.